Have you ever looked at something totally normal, and just wondered, is that all there is to it? What if, right under the surface, there's a hidden layer of information, a secret that completely changes what that thing is? Well, that's exactly what we're diving into today.
Okay, so let's start with a puzzle. Take a look at these two Rubik's Cubes. I mean, they're perfectly solved. Every color is right where it should be. Visually, they are absolutely identical. You could swap them and you never ever know the difference just by looking. But here's the question. Are they really the same object? It seems like a simple question, right? But trust me, the answer is way more complicated than it looks. So to really get our heads around this, let's set up a little thought experiment. This is a story about two people, one puzzle, and this fundamental clash between what our eyes tell us and what is actually possible.
Let's meet our two solvers. On one side, we've got Alex. For Alex, everything is by the book. They use all the standard moves, the cube does exactly what it's supposed to do, and the goal is simple: solve the cube so it looks right. But then, we have Quinn. Now, Quinn starts out the same way, but along the journey, they find that the cube behaves, well, differently. For them, it's not just about getting to the solved state. It's about a hidden property they discover along the way. So somewhere in the middle of twisting and turning, maybe by accident, maybe out of pure curiosity, Quinn stumbles onto something that's not in any of the manuals. A whole new rule to the game.
So what is this hidden move? Let's break it down. First, Quinn presses a tile straight in, orthogonally. And then, bam, the tile's color just flips to its opposite, so white becomes yellow. But here's the absolute kicker, the part that changes everything. That flip sticks. It persists. When Quinn rotates that face, that newly yellow tile moves right along with it. It's like the cube now remembers that this flip happened. This one single hidden move, it opens up a whole new dimension. We're not just looking at a colorful puzzle anymore. We're peeling back the surface and diving into a much, much deeper layer of reality, one based on hidden information.
Now, there's a technical name for this: orientation parity. But you know what? Just think of it like an invisible on-off switch on every single tile. This switch keeps track of whether a tile has been flipped an odd or even number of times. It's a memory, a history, that's completely invisible when you just look at the cube's surface.
And this is where it gets really wild. Take a look at this chart. From Alex's point of view, the cube has a certain number of possible combinations, right? Let's call that X. That's Alex's reality. But for Quinn, who knows about the secret flip, every single one of those states now has a hidden twin, a flipped version. So the total number of possible states, Quinn's reality is literally double the size. This one move doubled the entire universe of the puzzle.
So let's go back to our two solved cubes. Alex's cube is exactly what you see. It's solved. End of story. But Quinn's cube, well, it looks identical, but it's carrying a secret. It has a history of flips written into its very structure, like invisible ink. It's fundamentally a different object, carrying a memory that Alex's cube doesn't have. And this brings us to a huge philosophical showdown. It's appearance versus structure. It's not just about a toy anymore. This is about what we even mean when we say something is real. So you basically have two competing views on what's real. Alex's view is something called instrumentalism. It's super practical. It says, hey, if you can't see it or measure it, it doesn't meaningfully exist. If the cube looks solved, it is solved. But Quinn's discovery points to another idea: structural realism. This says reality isn't just what you see, it's defined by all the things you can do to it, all the rules, seen or unseen. That hidden flip is a possible action, so that hidden property is absolutely real. This quote really just nails the whole idea, doesn't it? An object is defined not by what it displays, but by how it may be acted upon. The cube's true identity isn't just its pretty, solved face. It's in its potential, the complete set of rules that govern its behavior, both the ones we see and the ones we don't. Okay, so you might be thinking, this is a fun thought experiment, but it's just a toy, right? Well, no. This idea of hidden properties, things that are only revealed when you interact with them, this is at the very heart of the unseen world of quantum physics. Believe it or not, this simple cube is a perfect model for some of the biggest ideas in science. Take quantum phase, for example. It's a property of quantum particles that's totally invisible on its own, just like our tile flip, but it becomes absolutely crucial when those particles interact. This whole idea also connects to things like gauge freedom and hidden variables in physics, and it all boils down to the same question. Are these hidden structures just math tricks we use, or are they a real, fundamental part of reality itself? So here's the big takeaway. The crucial point is this. Reality might be defined more by what you can do than by what you can just look at. We can't always trust passive observation. What an object can be transformed into, the full set of its possibilities, that might be way more fundamental to what it is than just its surface-level appearance.
Which brings us all the way back to the beginning. Two cubes. They look the same, but one has a different history, a different potential. Are they the same? Our little experiment here suggests, no, they're not. And it leaves us with this one final massive question to chew on. What if reality itself has a hidden face, a deeper structure, just waiting for the right interaction to show us what's truly there?